Hello again everyone and welcome back to the Underground. Today we're going to be taking a look at how to receive JS8Call messages without a license and without relying on any sort of internet connection. As we've already learned, there is a very easy way to receive JS8Call messages using an online software-defined radio or SDR. This is a great way to learn how to use some of the features of JS8Call and kind of get more familiar with how HF radio works. However, when it comes to emergency preparedness, using an internet-based source is probably not the best option. So today, let's take a look at how we can do the exact same thing with a little bit more effort using offline sources. There are two main options to receive JS8Call messages, or really any kind of digital data mode, offline. Depending on what kind of hardware that you have already on hand, and depending on how much money you're willing to spend, and depending on your personal preference, you can use either one of these methods. The choice is up to you. The first option is to use an SDR dongle like the RTL SDR V3 in conjunction with an HF radio antenna and some software. The second option is to use a shortwave listening radio, such as a C Crane radio, or in this case a GP7 SSB radio from Countycom. Pretty much any shortwave listening radio will work. This is kind of a backwards way of doing it, but I did want to show this method because it, one, helps illustrate how all of this stuff works, and two, if you don't have time to get an SDR, or if you already have a shortwave listening radio and you want to try this out before buying an SDR, you can do that as well. Alright everyone, I understand that this can be a little bit confusing for those of you who are maybe new to radio, so I thought I would start with actually option 2 when demonstrating how some of this stuff can work. In a last-ditch, extremely contingent situation, a lot of people might find themselves with this exact setup right here with nothing else. They may have a simple shortwave listening radio and a Windows computer with no internet access at all. So let's start by doing a very quick and dirty example of how this might actually work with nothing else other than what you see right here. Again, there are many ways to skin the cat when it comes to working with JS8Call, but at the end of the day, all we are doing is piping in audio that we receive over the airwaves through a radio into this program to decode. How we do that can vary, and let me show you the most basic way of doing this. The absolute simplest way of doing this, with arguable success, is to simply turn on your radio and let the audio from the speaker of this radio go into the microphone of your computer. So over here on JS8Call, we can open up File, Settings, Audio, and select the input method as your microphone array. Then we can exit out of that, open up your radio over here, and on your radio, depending on what yours may look different, of course, but we're just going to tune this to 7078 megahertz in SSB mode in upper sideband mode. Once we have our radio programmed to the right frequency and the right mode, we can extend the whip antenna and hopefully get something. These stock whip antennas for HF frequencies for digital modes like JS8Call are not the best. They're not the greatest. But you might want to try this before you move on to something else or before you buy a dedicated antenna. Again, this is the last-ditch method using the equipment that you might have on hand if you didn't really prepare too much ahead of time. So we've got our whip antenna extended here. Our JS8Call is programmed to listen to the microphone of this Windows tablet here. So let's go ahead and turn up our radio. And I know you might have a hard time hearing me just a little bit over that, but basically we're going to, again, take the audio from the speaker of this and pump it into JS8Call. Turning off our radio here for just a moment to conclude this example. This is, again, a quick and dirty method. You're probably not going to hear too many signals coming in through this particular method, but it does work, again, using very little infrastructure. Moving up in terms of effectiveness, what we might want to do, the very first thing, is stop using this small aerial and go ahead and go with a wire antenna. So this is just a simple wire antenna that I've got strung up through the room here, and this particular one is just a simple reel antenna. It comes with a little adapter so that you can plug in the antenna to a little clip here, which can then clip directly to the aerial on the radio. So now we're actually able to get pretty effective reception on this little radio, pumping it into JS8Call. Now again, you can stick with the whole speaker into the microphone of your computer, but again, moving on up the line, there are more effective ways of doing things. And the next most effective way of doing this is with a USB sound card interface and a 3.5mm aux cable. So this is, again, a very simple device. It's just a simple USB sound card interface. They're about, I don't know, $5 to $10 online. I usually keep one or two of these with all of my radio stuff, especially if you have a shortwave receiver. I would very strongly recommend keeping one of these and an auxiliary cable with it so that you can plug it into your computer like so. Then on this end, we can plug in the auxiliary cable into the microphone jack like that, and plug the other end of the auxiliary cable into the headphone jack of the radio. Now we can turn up the volume on the radio, and we shouldn't be able to hear anything because this is now going into our computer. Once we have all of this plugged in, we've got our radio set to the right frequency, the volume's turned up, and we've got our real antenna stretched out across the room, we can open up JS8Call again, go to File, Settings, Audio, and instead of choosing the microphone, we can choose the one that says Microphone USB Audio. And clicking OK, now our JS8Call program is decoding the audio that it is hearing from this radio. And as we can see, we already have messages coming in being decoded, some heartbeats here and there from all the way across the country. So that's a pretty cool way of actually using a shortwave radio, which you may already have on hand if you're into sort of emergency preparedness. You've got your shortwave radio, plug it into JS8Call and see what you hear. It's a pretty cool way of doing that. So this is a pretty cool setup if you just wanted to use a shortwave listening radio to pipe audio into JS8Call. This is a great way to do that, but again, moving on up the ladder, there's another thing you can do. If you don't like all these wires and you just want to kind of, use this tablet sitting on your couch at home or something like that, and you want the radio to be in an ideal position for listening, what you can do is actually use a Bluetooth transmitter that plugs into the audio jack from your radio. So this exact setup here is a Countycom GP7 SSB radio. It's a nice little compact radio. People kind of like it a lot because it's got good battery life, and there's some other features that make it a pretty good choice for a small shortwave radio. But one of the things I like about it is that it's decently compact, and you can buy one of these aftermarket Bluetooth devices and using some double-sided tape, just kind of stick it to the side. And as we can see here, the audio is coming from the headphone jack on the radio here. It's going along this auxiliary cable to the Bluetooth transmitter, and here on my computer is actually synced with the Bluetooth device. So now I can put this radio using a real antenna or whatever I wanted to do. I can put this somewhere, outside of my reach, where it's a little bit more effective to receive, and wirelessly do the same thing, because now the audio is coming from this Bluetooth device into JS8Call. I don't know if this is going to be useful for every user, but I think it's pretty cool. I found it to be kind of handy. Again, experiences may vary, but I thought this was kind of a cool option. It's nice, compact, and is a great way to get a little bit more everyday use out of a shortwave radio.
Alright everyone, as we can see, the concepts that we're dealing with here are fairly simple, even if it seems kind of complicated. As we demonstrated with our shortwave listening radio, really all we're doing is listening to signals that are whizzing through the air, and we're decoding that as audio. We're piping that audio into a program called JS8Call that decodes it. If we want to do exactly the same thing with a software-defined radio, or SDR, there's a couple of other steps that we need and a little bit more software that we need to actually make this all work. So here's what we need to get started. We need to download 4 pieces of software to make all of this work. The first is SDRSharp. We need to download SDRSharp from this webpage here. Just click download and extract that zip file to whatever folder you want to work out of. Next we need JS8Call, which we can download here by clicking the download tab and downloading whatever version that we have. Up next we need VB audio cable. This is a virtual audio cable that we can download here, and we also need a program called BKT Timesync, which we can download here by clicking this download button. All of the software is free and you could download it very easily. Once we have everything downloaded and extracted, we can open up SDRSharp first. So before we get started with the actual program, we need to install the right drivers. Now, this is a step that a lot of people tend to forget, so I'll mention it right here, right up front. And that is to click this install-rtlstr.bat. It's a simple bat file that all it does is when you double click it, it installs the correct drivers for SDRSharp to actually work. So this is something that you're going to need to do really before you get started with SDRSharp. Now I of course have this already installed, but you simply just press any key and it will automatically run this for you. Once we have that driver installed, we can open up SDRSharp if you want. Doesn't really matter. You can do some of this stuff out of order. I'm just going to minimize it for now and kind of get it out of the way so that we can work with the next thing, which is our virtual audio cable. Now again, very simple. Once we have installed a VB audio cable, this is the kind of interface you're going to get, and you'll have a big giant button right here that says install driver. I've already done it. It's already working on my computer, so now I have the remove driver button. But again, simple, one click to install the driver, and we're done with VB audio cable. To make sure that VB audio cable is installed and working, what you can do is go down here to the bottom right and click your speaker button on your PC. And see if you have an option to select the playback device as cable input. If you have the option to select cable input as your playback device, that means you're working. Everything's good to go. So you can leave that. Next is to replace the driver that Windows erroneously installs for your SDR device. Now again, Windows is kind of stupid when it comes to SDR devices. You get the device, you plug it into your USB port, and Windows installs the incorrect driver every single time because it thinks that it's just some kind of generic USB device. Because this is such a problem, an entire third-party piece of software exists to correct Windows's mistake. And that program is called Zadig. Once we plug in our SDR dongle to our computer, we can open up Device Manager and see which device it comes in as. Almost always it's going to be bulk in interface 0. So in Zadig here, what I can do is select Options, List All Devices, and from this drop-down menu, select bulk in interface 0. That's the one you want. In this case, I already have the correct driver installed, but again, if you were just doing this for the first time, you would click this button here to install the right driver. Once we've installed this driver with Zadig, we're done with that. We can move on to the next step, which is BKT TimeSync. Now, if you're not familiar with this program, what it does is it changes your PC's clock to be super accurate. JS8Call, in order to decode messages, needs for everybody's time to be kind of copacetic, right? Because JS8Call operates in windows of 15 seconds, everyone on JS8Call needs to have really accurate time. This program allows you to set that time in a few different ways. Primarily, it can use the internet to sync your time with the atomic clock. It can also use a GPS dongle, so if you're off-grid, it will allow you to use a GPS satellite's time to sync your clock so that everything works and you're able to decode messages in JS8Call. If you are connected to the internet, you can run this software and click Sync Now, and you'll get a little message here that says time was successfully synchronized using NTP server. But again, we're trying to do this a little bit off-grid, right? And using the internet is not exactly a great plan in an emergency. So, you can also come up here and configure your GPS. I have a USB GPS dongle installed into this computer, and it is using COM port 3. I don't have a GPS lock right now because I'm recording this inside, but this software is smart enough to realize, hey, let me go ahead and use the GPS instead of the internet. So if I disconnect my computer from the internet and click Sync Now, it will sync using a GPS clock. These are the two primary ways you want to be using JS8Call because it's the easiest. There is a way, which I will show you in a moment, inside JS8Call to do this completely off-grid with no satellites and no internet, but it's a little wonky. That's why we're covering this method now, because it's probably the least frustrating method to work with at the moment. Usually I like to run BKT TimeSync every time I start up JS8Call. It's just kind of a habit to get into. launch the program, sync your clock, and it's a little easier to work with that way. Okay, now that we've gotten all of our drivers installed and we've plugged in our SDR and everything's working, we can open up SDRSharp and finish up the configuration before moving to JS8Call. Opening up SDRSharp, we have a few settings that we need to make sure that we change. Remember, SDRSharp is the software program that's going to be controlling our software-defined radio. This is the control center for the whole thing. So the first thing we need to do is open the menu up and go to Source and make sure RTL SDR USB is selected. This is going to tell this software to listen for signals coming through the SDR plugged into our USB port. We need to do the same thing down here underneath this source menu, and we need to make sure that the device is selected as generic RTL whatever. As long as there's something here, that's probably going to be your SDR. Usually if you have a problem with setup or your SDR isn't working, this will be blank. But in my case, the only thing I have here is just the generic RTL device. We also need to go down to sampling mode and make sure that we choose direct sampling at Q branch. This setting here highlights why most SDRs are not created equal. There are some devices that cannot do this. This is also a pretty big debate in the SDR world, which I won't bore you with right now, but needless to say, the RTL SDR v3 is physically capable of direct sampling down at the HF frequencies. If you are using a different device that does not allow this option, you might find that you go up here to tune your frequency and you can't tune below a certain frequency because that SDR is not meant to go this low in frequency. So the RTL SDR, we have to do a little bit of cheating the system, so to speak, by direct sampling the signals that are coming into the device. So we're giving up a lot of efficiency that's normally used, but this allows us to use an RTL SDR v3 without purchasing any kind of special hardware, which we may talk about at a later date. For now, if you're using the RTL SDR v3, this will work. We also need to make sure that under the radio tab, USB is selected. Remember, we're going for upper sideband because we're dealing with digital data modes. Also need to make one final change before we head over to JS8Call, and that is to change the output to our sound card. So if I expand this a little bit, you can see that we want the one that says usually like Windows Direct Sound Cable Input VB Audio Virtual Cable. That's the one you generally want. You can try a few of the others. They're depending on your installation and what other devices you have, you may see multiple virtual audio cables, but really you want to choose the one that just says Cable Input. And now we can click the play button and start listening to our frequencies. So as we can see, we've got the main JS8Call calling frequency 7.078 right here, and we are piping the audio that we're hearing on this frequency through our SDR. We're piping that audio into JS8Call. So let's go ahead and minimize this, leave it running in the background, and bring up JS8Call. Now as we can see here, I can immediately tell what's going on with JS8Call. This is wrong. You should never see in JS8Call these vertical lines. This means one of two things. One, you've got a heck of a lot of interference, or you've got the wrong audio setting set. So let's open up File, Settings, Audio, and there we go. There's our problem. We need to change the input to cable output. This is sort of like plugging in the other end of that virtual audio cable. Click OK. Our waterfall should clean up quite a bit, and we should start seeing, after a while, some messages start rolling in. Now one can see here, I've already started getting some heartbeats coming in, which is impressive considering I'm just using a very tiny little whip antenna with this SDR. And these guys are not even close to me. So this does prove and show that the whip antenna that you can use with an SDR, it does work, just not very well, not as well as you might expect. There's one thing that I do want to note though on this page, and that is this giant red bar over here. This is the handy little volume meter, basically, to let you know that your volume is too high. So what we want to do is bring this red bar down into around 70 or so. As we can see right now, we are at about 87 decibels. So to change that, we pull up our handy dandy SDRSharp, and arranging it so that you can see what I'm talking about here, we've got our volume up here way too high, so let's back it down a little bit into something that's a little bit more reasonable. so that it doesn't sort of blow out the speakers, so to speak, in JS8Call. So around 70, as long as the bar is green, you're good to go. If you have it too low, like that, you might have a hard time decoding some signals, but around 70 or so is good to go. So now we can start see that we're getting some heartbeat messages coming in. Now before it goes away on my waterfall, let me go ahead and grab this image so we can talk about it for just a second. So this right here is what a standard message in JS8Call looks like. This one's extremely faint, but as we can see, the actual message itself is coming in between the green lines. It's coming in between all of these green lines moving down the screen. These green lines delineate time slots of 15 seconds. So what I was saying earlier about the whole time sync thing, you need to make sure that your messages are between the green lines. If they're in the green, you're good to go. If they are not in the green, either one of two things has happened. Either one, your time sync is off, meaning your clock is inaccurate, or the other guy that's transmitting has an inaccurate clock. So if you ever see messages that are coming in like this, and they're splitting the green line like that, that means either you or they is in the wrong. So you just want to make sure that your time is accurate. Now again, there is a feature within JS8Call to handle this just in case you don't have any third-party software and in case you don't have an internet connection. Again, I'm guessing that if you're watching this video, you're probably wanting to know how to do this completely off-grid, right? That's the whole purpose of learning how to do this. So there is a way within JS8Call to make these messages basically sync up, so that if you're seeing a bunch of messages that are split like so, you can basically shift your time, you can drift your time, so that basically you're all wrong together. In a total apocalyptic collapse where there is no time server, there's no way of syncing your clock with like a radio source, there's no way of syncing your clock with a GPS, and there's certainly no internet. What you can do is use the time drift within JS8Call to basically be all on the same page. So here's basically how the time drift function works. If you click Start Automatic Time Drift, and you can set it to stop after 2 or 3 decodes, doesn't matter. What JS8Call is going to do is it's going to listen for messages. And after a while of listening to messages, however long you define it, JS8Call is going to assume that everybody else that it can hear is right and your computer is wrong. So it will change this time drift factor here, this number, to match up with everybody else. So that's a pretty cool feature, right? You don't have to have a GPS lock. You can do this solely by radio. Now you do need to have the ability to receive traffic, right? If you can't hear anybody else, your time is not going to be accurate. But if you're in if we're playing the what if game and going down the total apocalypse route, anytime you can visually see traffic here on the waterfall, and as soon as you see someone transmitting, you can start the automatic time drift, and as they transmit, your clock will sync with theirs and you can communicate with them. So even in a total Hollywood-style apocalypse scenario where you have nothing but an HF radio in the woods, you can still communicate with someone else using JS8Call. That makes this platform a very powerful tool. Now, the problems with using automatic time drift all the time is that it's a little bit buggy. By that I mean sometimes it tries to average out all of the times. So basically, if you've got 10 messages here on your waterfall and one person is off, it's going to throw off your time sync so that you still don't hear anybody. But if you give it enough time, JS8Call is smart enough to where it'll sync up with everybody so that you're all on the same page. I personally don't like to use automatic time drift except in like, a training situation where I'm trying to not use a GPS receiver or something like that, because it just takes a little bit of time and you tend to lose like the first part of a message because you have to rely on someone constantly transmitting so that you can start your automatic time drift. But that's just me. Either way, it's not a perfect solution, but it does work, and it's what you would use if you did not have a GPS and if you did not have an internet connection. This is how you would sync your time. So that's basically it for the software side of things. Now, like I mentioned, I have been intentionally neglecting what is arguably the most important part of this whole thing, and that is your antenna. So let's jump back to the tabletop and we'll talk about what antennas you can use.
Alright everyone, when it comes to antennas, you have quite a few options. So I'll start with what I prefer to use for a receive-only setup. For most people who are not interested in going down the whole HF radio route, and they're not really interested in radio as a hobby, and they're not really interested in continuing to learn about radio, the bare minimum I would recommend for most people is a simple, pre-made, commercially available shortwave reel antenna. These normally come with an adapter so that you can either plug them directly into a radio to receive, and if you don't have a radio with an antenna jack on it, you can plug this into itself like I showed earlier and clip this directly to the aerial on a shortwave radio. Now again, I prefer these because they're only about 10 to 15 bucks, and it comes with the adapter usually. So by the time that you've went ahead and built a homemade option, you could have just bought this, because the bare wire in here is sometimes more expensive to just to make. It's easier to just buy something. Plus the rugged cases that these come in really makes it easy to kind of reel these back up and put away and store. So this is what I would recommend for most people who want to use a shortwave listening radio or an SDR. This is what I would recommend. Again, there are other options though. Speaking of the shortwave radios themselves, if you were to pick up a shortwave listening radio, it's always going to have a whip antenna. Now, if you like using whip antennas, that's cool. I use them a lot, even though they're not ideal for listening to JS8Call. Sometimes it's easier to throw this and this alone in a bag and go. One thing that I would very strongly recommend is purchasing a radio that has a replaceable whip antenna, because I tend to snap these off quite a lot. They're a pretty delicate piece of hardware, even though they're included in all radios. You know, it's just not really a rugged piece of gear. So this one, the Countycom GP7 SSB, has a user replaceable antenna, and you can buy these. You can buy several of these and keep them in your bag, so that when or if you snap one of these off, you can easily replace it. There are a million different kinds of shortwave listening radios, but again, you might want to make sure that you choose the right version. For instance, this version of the C-Crane Skywave SSB, this particular line of radios is probably one of the more feature-rich radios that you can buy, because it has all of the traditional stuff plus the airband. But this is a model from a couple of years ago, and as we can see here, it does not have an external antenna jack like the Countycom one does. So this one has an actual antenna jack so that we can plug in. We don't have to use the adapter. We can plug this antenna directly into the radio like so and run that. That works on all of the modes on this radio as far as I know. It's marked as just being a long wave and medium wave antenna, but it works on the short wave as far as I've been able to tell. So that might be something you want to consider, because when it comes to this, somewhat expensive radio, I still have to potentially introduce a moment of failure when I clip this antenna adapter in. So that's something you might want to keep in mind if you're trying to shop for a shortwave listening radio. Now, when it comes to using an SDR, you have quite a few options. So most SDRs, or the one that we have used so far, is the RTL SDR Model V3. Now this one, almost all SDRs are going to come with an SMA adapter here. So the first thing you might want to pick up is a simple SMA to BNC adapter. This will allow you to use a lot of the accessories and antennas that are made for HF radio. So if you screw this together like so, you can now use your HF antenna that you might be using for transmitting. I like to use gear that is a bit redundant sometimes, so I end up taking multiple HF radio antennas, but it's nice to be able to use one antenna for everything. So if you wanted to purchase an antenna, or if you wanted to make an antenna, this is going to allow you to easily attach your SDR to whatever HF antenna you build. Something else I would recommend that is probably a little bit controversial is buying one of these whip antennas for your SDR. Sometimes the older versions of this used to come with these, or at least when I bought mine, it came with them. But the newer versions come with a different kind of antenna array. You might want to pick up one of these simple SMA whip antennas. You can find them all over the internet for just a couple of dollars a piece, and you can buy them in multi-packs. The reason I would recommend this is because, one, it's very small, very lightweight, it takes up no space. Again, it is a whip antenna, so it's very fragile, but it allows you to have something quickly in your bag so that you can use your SDR with some level of effectiveness. Also, it allows you to have a more easy time of attaching your shortwave reel antenna like so. If you wanted to do something like this, you could. Yes, it's not ideal, it's a little weird, and it's a little, unnecessary perhaps, but this is a good setup. It's multifunctional. You can use it in a bunch of different ways, and this is probably what, again, the lowest common denominator would use, which is people who are not exactly interested in radio. They're interested in information, so they're not really interested in the hobby of radio. That's perfectly fine. Most people are like that. I'm exactly like that as well. I don't necessarily enjoy radio as a hobby. I like to use it for information exchange. So for those people who aren't interested in building your own antennas or anything like that, this is probably what you want to go with for now. Buying a real antenna and one of these with your SDR and going from there. For those of you who are interested in going down the rabbit hole of HF radio and improving your skills, you might want to try one of these. This is a BNC binding post adapter. Sometimes you'll see them called Cobra heads. And basically this allows you to hook up your SDR here using, again, our binding post adapter. Now we can hook in two wires, a wire here and a wire here, and depending on what band you're on, you can make a very simple, quick and dirty dipole, an unbalanced dipole for receiving traffic. It can be very, very effective. If you wanted to just use this as well and have a random wire going from here and a random wire of the same length going that direction, you might find that you get decent reception as well. Again, when it comes to receiving signals, we have to differentiate between receiving and transmitting. Transmitting on something like this is going to be very hard to do because an unbalanced antenna it has a lot of potential for error. But when it comes to receiving, don't get caught up in a lot of the stuff that hams talk about when we're talking about balanced antennas and standing wave ratio and all this complicated stuff. Transmitting on an antenna is hard to do. It's a lot more complicated than just receiving. So please keep that in mind, is that you don't necessarily have to go out and purchase a very expensive, sometimes, HF antenna. You can just use a piece of wire. And that's exactly what I would recommend for the last ditch method. In a last ditch, extremely contingent circumstance where you didn't prepare not one bit, you might be able to have a whip antenna, or let's say a whip antenna on our shortwave listening radio. And really, all you need to do is get a random piece of wire. This is a random unmeasured piece of wire that I've stripped the end off here, and all we need to do is literally wrap that wire around the aerial antenna of the shortwave listening radio. Hopefully we can get a decently tight connection there, police it up a little bit, make it look decently okay, and string this wire here out across the room and get it up as high as you possibly can. And that's what you might be able to do. This will increase the range. Basically just turns this whip antenna into one of these real antennas. So it's not ideal. Obviously your connection here is not going to be as solid as you might want, but again, if you didn't prepare, if this is all you have, this will work just to receive message traffic. Obviously you couldn't use this to transmit off of unless you did some serious modification, but again, receiving signals is very, very easy on HF frequencies. Now the whole random wire thing wrapped around the aerial, the whip aerial here, is probably not something you want to do every day. Again, if we're trying to use receive-only radio messages, network, stuff like that, if we're trying to use this on a daily basis, you might want to have a little bit more dedicated system. So something like using just random lengths of wire is fine, but really what we're trying to do is reduce a lot of the barriers when it comes to radio. Dragging out, your HF or your shortwave listening radio here and stringing up an antenna and stuff like that, it gets a little tedious for those people who don't like the hobby. However, what is far more easy to do is for me to grab this out of my bag, set it in my living room or something like that, pop this antenna in like so, string it out across the room, and connect to it via Bluetooth. Sit on my couch and listen to signals coming in. That is the easiest thing to do, and it's even though it's not the most efficient, sometimes we have to account for the human factor, right? You have to make this stuff to be where you want to use it. If I have to use my SDR here and fire up 4 different pieces of software to get this to work, well, I can do that, but a lot of times I'm not going to want to do that. The choice is really up to you. I just wanted to offer 2 different options for those people who might not be super interested in the software radio side of things. They may already have a dedicated shortwave radio that they like to listen to, or they've bought over the past couple of years of craziness, and they've got this sitting in their emergency kit. Well, here's a way you can actually put it to some good use. You can get yourself a Bluetooth dongle or a sound card interface and an auxiliary cable and plug this in and you're good to go. So yeah, hopefully this is helpful for all of you who wanted to have a more listen only, receive only, totally off-grid JS8Call setup. You can use this not just with JS8Call, but other data modes as well. You can receive and decode Morse code, you can do RIDI, you can do all kinds of other data modes with this setup. It just, the only thing that changes is the software on your computer that listens to the signal. But as long as you can pipe in audio from either one of these or one of these, as long as you can pipe that into your computer, you're good to go. So thanks again for watching, everyone. Hopefully this has been helpful, and we will see you next time. And as always, fight in the shade.